of emerging technologies in enhancing that security. I think that by the end of this workshop, you will hopefully have the knowledge and skills needed to secure cloud systems and protect your own cloud systems against unauthorized attacks and other potential security threats. So let me just admit everyone to the meeting. Okay. Let's get started. So we'll start with the introduction to cloud security. Cloud computing refers to the delivery of computing services and includes servers, storage, databases, networking, software, analytics, and intelligence over the internet to offer faster innovation, flexible resources, and economies of scale. Basically, it allows organizations to consume resources as a service and to only pay for what they use, instead of having to invest in and maintain on-premise infrastructure. So that's one benefit of it. Cloud computing has rapidly gained popularity in recent years due to its cost effectiveness, scalability, and accessibility. According to some recent studies, the global cloud computing market is expected to grow significantly in the coming years, driven by the increasing demand for cloud-based solutions and services across various industries. As more and more organizations adopt cloud computing, the need for securing sensitive data in the cloud becomes increasingly important. Cloud security refers to the measures and technology used to protect data, applications, and infrastructure in the cloud, from stuff like unauthorized access, theft, damage, or disruption. Basically, in this workshop, we will explore the key concepts of cloud security, including the types of security risks and vulnerabilities that organizations face in the cloud. We'll also cover best practices for protecting sensitive data. We'll also look at various cloud security solutions and strategies, including stuff like encryption, access control, network security, and incident response. I think that protecting sensitive data in the cloud is crucial for organizations to maintain their privacy, confidentiality, and security of their information. And it's a requirement if they want to comply with legal and regulatory requirements. We'll also covering that. But in essence, if our organization implement effective cloud security measures, they can mitigate the risks associated with storing and accessing data in the cloud, and they will basically ensure that their information remains secure and accessible. Okay. We'll be covering some threats that are common in cloud security. Basically, in the cloud, organizations are exposed to a wide range of security threats, including data breaches, cyber attacks, insider threats, misconfigurations, malware. I have listed here every top 15 cyber threats from European Union Agency for Networks. Some of the most common cloud security threats include unauthorized access, data theft, data loss, and service disruptions. In the cloud, threat vectors are different from those in the traditional IT environment due to its unique characteristics of cloud computing, such as shared responsibility and the use of third-party services. For example, in the cloud, the attack surface is much larger and more dynamic, and there is a high risk of data breaches and misconfigurations due to human error. Threats to cloud systems can have serious consequences for organizations, including stuff like data loss, financial losses, reputational damage, and legal and regulatory penalties. In addition, cloud service disruptions can result in a downtime and reduced productivity, impacting the ability of organizations to deliver services and meet customer demands. All right. As the threat landscape in the cloud continues to evolve, it is important for organizations to stay informed about the latest threats and vulnerabilities, and basically to proactively implement measures to mitigate them. This includes regularly reviewing and updating security policies, conducting regular risk assessments, and investing in cloud security solutions and technologies to detect and respond to threats in real time. We'll also be covering that in a minute. Okay, let's move on. The principle of least privilege states that users should have the minimum access necessary to perform their job functions. Access controls refer to the measures put in place to manage and restrict access to resources, such as data and systems. Implementing least privilege and access controls helps to reduce the risk of unauthorized access and data breaches in the cloud. Data encryption refers to the process of converting plain text into ciphertext to basically protect the confidentiality and privacy of sensitive data. Regarding the cloud, encryption is a key best practice for protecting sensitive data, basically because it helps to ensure that even if data is intercepted or stolen, it will be unreadable without the encryption key. Regular security monitoring and testing are essential for detecting potential security threats and vulnerabilities in the cloud. This includes continuous monitoring of systems and networks for signs of intrusion or anomalies, as well as regular security testing to identify potential vulnerabilities and ensure that systems and configurations are secure. Stuff like security policies, standards, and procedure are a cornerstone of a strong cloud security program. They provide you with a framework for managing and controlling access to resources, as well as guidelines for secure configuration, monitoring, and incident responding. By implementing and regularly reviewing security policies, standards, and procedures, organizations can ensure that their cloud systems are secure and compliant with relevant regulations and standards. Okay, let's move on. Now we'll covering something that's called cloud provider security. Basically, the shared responsibility model is a key concept in cloud security and refers to the division of responsibility between the cloud provider and the customer. Under this model, the cloud provider is responsible for securing the underlying infrastructure, while the customer is responsible for securing their applications and data. Uh, Understanding this responsibility model is essential for organizations to effectively manage their security in the cloud. When evaluating cloud providers, it's important to understand their security features and capabilities. This includes assessing their security certifications, such as ISO, as well as their approach to access control, data encryption, and incident response. Evaluating the security features of cloud providers will help you make informed decisions about which providers to work with and how can you configure their security to meet your specific needs. Uh, Organizations can work with the cloud providers to enhance their security in several ways, including some like uh, implementing multi-factor authentication to strengthen access control, using encryption that we covered recently, uh, using secure data storage solutions to protect sensitive data, to regularly monitor and test systems to identify potential vulnerabilities, and basically those are those are ways that organization can work with their cloud providers to strengthen their security. Um, Performing due diligence, I think, is an essential part of cloud provider selection process. This includes researching and evaluating the security features of different providers, as well as understanding their security policies and procedures. By performing due diligence, you can ensure that you select cloud provider that meet your specific security needs and requirements. Okay, let's move on. An incident response plan is a crucial aspect of cloud security. It outlines the steps to be taken in case of a security breach or other incidents that would impact your cloud systems. Having a well-defined incident response plan can help minimize the damage and get your systems back to normal operations as quickly as possible. Uh, The incident response process typically involves several stages, such as preparation, identification, containment, eradication, recovery, and finally, lessons learned. Having a well-defined incident response plan can help ensure that the appropriate steps are taken in a timely manner to minimize the damage and restore normal operations. Uh, Disaster recovery is the process of restoring normal operations after a disaster or other disruptive event. Businesses continuity planning ensures that the essential functions of your organization can continue even in the event of a disaster. Uh, it's important to have a well-defined disaster recovery plan in place to minimize downtime and ensure the continued availability of critical systems. Regular testing and updating of incident response and disaster recovery plans is essential to ensure that they remain effective and up to date. Regular testing can also help you identify any gaps or weaknesses in your plans and allow you to make any necessary changes to improve their effectiveness. Okay. Cloud Access Security Brokers, CASB, is a security solution designed to provide an additional layer of security for cloud systems. Purpose of it is to provide you or organizations with visibility and control over cloud usage, including who is accessing what data and from where. They can enhance security by providing organizations with centralized management of cloud applications and the ability to enforce security policies such as access controls, data encryptions, and compliance with the industry regulations. They can also provide real-time monitoring and threat detection capabilities. There are different types of CASBs, including API-based, reverse proxy-based, and agent-based solutions. When you are evaluating a cloud access security broker solution, it's important to consider factors such as compatibility with your existing systems, ease of deployment and management, and the level of security they offer. Implementing such solution is a relatively straightforward and can be done quickly. The first step is to determine your security requirements and evaluate the different solutions available. Once you have selected a solution, you can deploy it and configure it to meet your specific security needs. Regular monitoring and testing of the solution is important to ensure it continues to provide adequate security. We can see a graph of how Cloud Access Security Broker functions. All right. Cloud computing allows organizations to store and access data and applications over the internet, which can lead to increased efficiency and cost savings. However, it also comes with the need to secure the data and networks against various threats. Network security in the cloud is an important aspect of cloud security and involves protecting the network connections used to access cloud resources. One important best practice for securing cloud network infrastructure is to implement secure protocols such as SSL or TLS for transmitting data. In addition, VPNs or virtual private networks can also be used to encrypt network traffic, providing an additional layer of security. Firewalls can also be used to control access to cloud resources by saying who can access which data and which incoming and outgoing network traffic is allowed. The security implications of cloud network architecture should also be considered. For example, it's important to understand the difference between public and private cloud networks, as well as the potential security risks associated with each type. Also, when you are evaluating the use of VPNs, firewalls, and other security solutions, it's important to consider factors such as compatibility with your cloud services, ease of use, and cost. Okay, let's move on. Now let's cover IAM, basically Identity and Access Management. We have a graph which is showing how IAM is working in the AWS infrastructure. This is an important aspect of cloud security. Its purpose is to control and manage access to cloud systems and the data stored within them. In cloud systems, IAM works by assigning specific permissions and roles to users, ensuring that they only have access to the data and systems they need to perform the job functions. This helps to prevent unauthorized access and protects sensitive data from being leaked or stolen. To effectively manage identities and access controls, it's important to implement best practices such as regularly reviewing and revoking access for inactive users, using multi-factor authentication, and implementing role-based access controls. It's also important to integrate IAM with existing security systems such as firewalls or intrusion detection systems to ensure that access is controlled and monitored from all angles. This can help to reduce the risk of security incidents and make it easier to detect and respond to threats. So basically, IAM plays a crucial role in protecting sensitive data and maintaining the security of cloud systems. It's really important to fully understand the purpose of IAM, implement the best practices for managing identities and access controls, and to integrate IAM with existing security systems to ensure that your cloud environment is secure. Data loss in a cloud system can occur due to various reasons, such as accidental deletion, unauthorized access, or security breaches. This data loss can cause severe harm to an organization's reputation and financial stability. Therefore, it's essential to implement measures to prevent such data losses. DLP, short for data loss prevention, solutions for cloud systems are designed to monitor and prevent unauthorized data transfers or storage of sensitive information. When you're evaluating DLP solutions, it's important to consider factors such as the type of data that needs to be protected, the level of control and visibility needed, and the scalability of the solution. Best practices for preventing data loss include implementing strong access controls, regularly backing up data, using encryption to protect sensitive data, and performing regular security audits to identify potential threats. Data classification and labeling is an important aspect of DLP because by categorizing data into different security levels, organizations can determine the level of protection required for each type of data. This information can then be used to create DLP policies that help prevent unauthorized access or transfer of sensitive information. Now we can see here the benefits of data loss prevention. Some standard industry regulations as GDPR. You probably wonder what that was, but you surely heard of it. As we mentioned before, protecting against malicious insiders who are looking to exfiltrate your data. For industry regulations, to comply with industry regulations, prevent ransomware from infiltrating the network, minimizing the risk of data breach, protecting employees against accidental data loss, and improving data security in the supply chain. Compliance and regulatory considerations. Compliance regulations are a set of rules and guidelines set by various organizations to ensure that companies and individuals are adhering to best practices for protecting sensitive data. Some of the commonly followed regulations in the cloud systems are HIPAA, PCI DSS, and GDPR. To To ensure compliance with these regulations, companies should establish strong security policies and procedures, regularly monitor and assess their security posture, and undergo periodic audits. Additionally, companies should work with their cloud providers to ensure that the cloud systems and services being used are compliant with the relevant regulations. Uh, Having a well-defined security and privacy policy is critical in ensuring compliance. These policies should outline the steps taken to secure sensitive data and protect the privacy of the individuals itself, as well as responsibilities of employees and third-party providers. Uh, Complying with regulatory standards can have a significant impact on cloud security, both in terms of cost and resources. Uh, Companies consider should carefully consider the specific regulations they are subject to and evaluate the impact on their cloud security posture. Um, they should regularly reassess their compliance status to ensure that their security measures are still effective in protecting sensitive data. APIs. Uh, API is short for Application Programming Interfaces. So APIs and microservices are key components of modern cloud applications. Uh, they are allowing communication between different parts of the system and with external systems. However, uh, they are they also create new security risks as they expose the underlying systems and data to potential threats, stuff like unauthorized access, manipulation, or theft. To secure APIs and microservices, it's important to adopt a defense in-depth approach, uh, covering multiple security domains such as network security, identity, access management, data protection, and application security. Uh, Now, like some of the best practices for securing APIs and microservices are to limit the exposure of APIs and microservices to only what is needed. As we can see right here, that we will not allow API or microservice to have a direct connection with the service provider, external service provider. Uh, Also, best practices are to implement authentication and authorization mechanisms to control access, using encryption to protect data in transit and at rest, monitoring and logging API and microservice usage to detect and respond to security incidents, and to regularly test and update the security of APIs and microservices. Uh, when using a third-party APIs, when using a third-party API or microservice, it's important to carefully evaluate their security features and practices and to implement additional security measures if necessary. This may include checking the security certifications of the provider, reviewing the security policies and procedures, or testing the APIs and microservices for vulnerabilities yourself. Uh, Encryption is a critical security measure for protecting data in transit and at rest, especially when using APIs and microservices to exchange sensitive information. Authentication is another important security measure as it verifies the identity of the users or systems accessing the APIs and microservices, and they ensure that only authorized entities can access the data. Together, encryption and authentication form the foundation for securing APIs and microservices, and they're essential for protecting the data and systems that they expose. Here is 4Cs in cloud native security. It's visually represented. I think it's pretty self-explanatory, but the point is to basically stack it to increase the security of the underlying system. In cloud native security, this kind of approach is called 4Cs. Traditional security approaches are based on hardware-centric perimeter security that focuses on securing data centers. Cloud native security, on the other hand, is built specifically for cloud environments and emphasizes the protection of data and applications. Cloud native security solutions must be implemented from the design stage and must be integrated into the development pipeline. This includes the use of encryption, access control, and threat detection and responses. Containers and serverless computing are becoming increasingly popular in cloud computing, and they can introduce new security risks. Kubernetes, an open source platform for managing containers, has built-in security features that can help organizations secure their applications and infrastructure. By adopting cloud-native security approaches, we can reduce the risk of data breaches, improving their security posture, and can enhancing their ability to respond to security incidents. Additionally, cloud-native security can help you reduce the cost and complexity of your security operation. SecOps, or security operations, is a critical component of cloud security, which involves the integration of security into all phases of software development lifecycle. The goal of SecOps is to improve the security posture of an organization by automating and orchestrating security processes, improving security visibility, and reducing the time to detect and respond to security incidents. One of the best practices for implementing SecOps in cloud systems is to have a centralized security management and orchestration platform. This platform should have the capability to automate security tasks such as vulnerability scanning, incident response, and threat detection. Another best practice for SecOps in cloud systems is to have a well-defined security process that is integrated into the development lifecycle. This process should include stuff like security testing, code reviews, security assessments, and basically it will ensure that all security requirements are met. Automation and orchestration play a key role in SecOps by allowing security teams to automate repetitive security tasks. This will help improve the speed and efficiency of security operations, reducing time to detect and respond to security incidents itself. A well-designed SecOps approach can bring numerous benefits to an organization by automating and orchestrating security processes. SecOps can help organizations to improve their security posture, reduce the time it's needed to detect and respond to security incidents, and reduce the overall cost of their security operations. Uh, we can see how Azure is handling SecOps monitoring here on this diagram. Uh, DevOps is a software development approach that emphasizes collaboration, automation, and communication between development and operations teams. In the cloud, DevOps helps organizations to develop, deploy, and manage applications quickly and efficiently. However, with the increased speed and agility of DevOps comes a need to ensure that security is not compromised. Implementing secure DevOps in the cloud involves integrating security into the software development pipeline. This includes implementing code review and testing processes, using secure configurations, and automating security testing and remediation. Additionally, organizations can also consider using security-focused tools, such as vulnerability scanners and firewalls, to help detect and remediate security threats. Uh, DevOps can have a significant impact on cloud security, both positively and negatively. Uh, on one hand, DevOps can help organizations to quickly identify and remediate security issues, reducing the risk of data breach. On the other hand, DevOps can also introduce security risk if security is not integrated in the development pipeline, or if developers do not follow secure coding practices. Integrating security into the DevOps pipeline helps organizations to ensure that security is considered at every stage of the software development process. This includes implementing security-focused tools and processes such as continuous integration and continuous deployment (CI/CD) pipelines to help ensure that security is built into the code from the outset. Additionally, security can be integrated into the testing process to help identify and remediate security threats before they reach the production. Okay, let's move on. Cloud adoption refers to the process of moving from traditional IT infrastructure to a cloud-based model. The main factors that drive cloud adoption include cost savings, scalability, flexibility, and improved operational efficiency. Organizations can take advantage of the pay-as-you-go model, where they only pay for the resources they consume. They can also easily scale their infrastructure up or down as needed without the need for physical hardware. To ensure a secure cloud adoption process, organizations should follow best practices, uh, such as conducting a thorough risk assessment, implementing multi-layer security approach, monitoring, auditing the usage of cloud resources, and regularly updating their security policies and procedures. As we mentioned before, it's also important to choose a reputable cloud service provider with a strong security and track record, and to basically establish clear security rules and responsibilities for all stakeholders. Uh, cloud adoption can introduce new security risks, such as data breaches, unauthorized access to resources, and misconfigured cloud services. To mitigate these risks, we need to understand the security implications of cloud adoption and take proactive steps to address them. This includes regularly monitoring cloud services for vulnerabilities, implementing multi-factor authentication, and encrypting sensitive data in the transit and at rest. So we need to involve security in the cloud adoption process to ensure a secure cloud environment. Security teams can provide valuable input on potential security risks, and we can help them develop a secure architecture and ensure that the security policies and procedures are in place to protect sensitive data. By integrating security into the cloud adoption process, we can minimize the risk of security incidents and ensure that confidentiality, integrity, and availability of our data and resources in the cloud is unbothered. Okay, now the future of cloud security. Uh, Cloud security is constantly evolving with new technologies and threats emerging regularly. To stay ahead of the curve, it's important to understand the latest trends and advancements in the field. Some of the key trends to look out for include the increased use of multi-cloud and hybrid cloud environments, adoption of cloud-native security solutions, and the growing importance of security operations, we mentioned before, SecOps, in cloud systems. AI and machine learning are playing an increasingly important role in cloud security. By analyzing large amounts of data in real time, AI can help organizations identify potential threats and respond to security incidents more quickly. For example, AI can be used to basically detect and respond to malicious traffic in real time, or even to automate the process of patching vulnerability in the cloud system itself. Now we are seeing the emerging technologies like 5G, edge computing, and the Internet of Things, IoT, are also having an impact on cloud security. As these technologies become more and more widely adopted, they will create new security challenges and opportunities. For example, the growing use of Internet of Things devices will increase the number of entry points into cloud systems, making it more important than ever to secure these devices and protect them from cyber attacks. Basically, if you want to stay ahead of the curve in cloud security, it's important to stay informed about the latest trends and advancements in the field. Regularly update your skills and knowledge, to attend industry events, and to participate in security communities. They can also help you stay up to date with the latest developments. Additionally, it's important to take a proactive approach to security, implementing best practices that we mentioned before, such as encryption, multi-factor authentication, regular security audits, and all of those can keep your cloud systems secure. All right. And I think, yeah, now let's recap the things that we went through. Basically, we covered various aspects of cloud security, including how to secure APIs and microservices, what is cloud native security, uh, cloud security operations, or in short, SecOps, uh, securing DevOps in the cloud, securing cloud adoption, and the future of cloud security. Uh, as organizations are increasingly adopting cloud technology, it is critical to ensure that the security of these systems is not compromised. Cloud systems store and process sensitive data, making them an attractive target for cyber attacks. Organizations must be proactive in securing their cloud systems to prevent data breaches and to protect their own reputation. Uh, Through this workshop, we have discussed some of the several best practices for securing cloud systems, uh, such as multi-factor authentication, encryption, regular security audits, and security in all your pipelines. I think that cloud security is a crucial aspect of technology and it has to be taken seriously by everyone. It's important to stay informed about the latest advancements and to adopt best practices for securing cloud systems itself. I encourage everyone to continue learning about the cloud security and to try implementing some of the practices that we covered today to protect their own sensitive data. Uh, okay, now